Hi everybody, it's Mr. Millington here. This video is all about finding the area of regular hexagons. And we're going to start though with a problem about finding the area of an equilateral triangle. You'll see why we're doing that once we get to the hexagons. So here goes. It says find the area of an equilateral triangle with a perimeter of 30 feet. So you're going to draw your equilateral triangle. And of course, if the perimeter is 30 and all three sides are equal, you can just divide by 3 and you would get 10. So each side is 10 feet. All right. So this is a triangle, so we want to do base times height divided by 2. Right now, we don't know what the height is, but there is, something pretty cool about equilateral triangles. If you draw the height down, the angles in an equilateral triangle are all 60 degrees. 180 divided by 3 would be 60. So this is a 60-degree angle here. This is 90. This angle up here would, of course, be 30 degrees then. So this is a 30, 60, 90 triangle. So you probably remember from your 30, 60, 90 triangles that there was a certain ratio that the sides were all in every time. You had like the 30-degree angle, the 60-degree angle. The side that was across from the 30-degree angle was x, the hypotenuse was 2x, and then the side across from the 60-degree angle was x root 3. So in this case, I've got 10 for the hypotenuse of this triangle right here. When I drop that height down, it split the base in half. So half of 10 would be 5. So I've got 5 there. And then that would make the long leg 5 root 3 based on the fact that this is a 30, 60, 90 triangle. So my base of the triangle is 10. My height of the triangle is 5 root 3. So my area is going to be 10 times 5 root 3 divided by 2, which is going to be 25 root 3. They gave us the units were feet, so this would be feet squared. So 25 root 3 feet squared. Ms. Rose and I are very happy with you leaving your answer with the root 3 in there. It's a nice exact answer. All right, this next one, find the area of a regular hexagon with a perimeter of 108 units. So we're going to take 108. This is regular, which means all the sides are the same. So we're going to divide by 6. So 108 divided by 6 gives me 18. I knew that was going to happen at least once. Hopefully that's the only time. So at 18. So each of these sides on this hexagon is 18. You don't have to label them all, but they're all 18. So something cool happens with a hexagon, a regular hexagon. When you could split it up if you draw in like the diagonals, and it actually splits up into 6 perfect equilateral triangles. You could ask me or Miss Rose why that happens. If we have time later, we can talk about that. But a regular hexagon always breaks up into 6 equilateral triangles. So from here, I'm just going to do basically the same process I did on that last problem. So like if I look at this triangle right here, I know that its base is 18. I know I can drop down in altitude. And I've got a 30, 60, 90 triangle in here now. So again, like this was an equilateral triangle right here, right? So what you can do is, this is 18. I split that base in half. That's 9. So now the height of the triangle is 9 root 3. So to find the area of one triangle would be the base of 18 times the height of 9 root 3 divided by 2. And when you calculate that out, that comes out to be 81 root 3. But we want the area of the whole hexagon. Well, the hexagon is made up of 6 of those equilateral triangles. So the area of the hexagon is going to be 81 root 3 times 6. So 81 root 3 times 6 gives you 486 root 3. And this is just units squared. All right, so basically the strategy for a regular hexagon is you split it up into equilateral triangles. you find the area of one of those triangles, and then you multiply by 6. Let's look at one more problem together. All right, find the area of the shaded region if the hexagon is regular. So these shaded region problems are really cool. Usually, you find the area of one of the shapes, and then you subtract out a shape that's not shaded. So in this case, we find the area of the hexagon. So the shaded is going to be the area of the hexagon minus the area of the rectangle, because there's a rectangle in there that's not shaded. So if I just subtract out the area of that rectangle, what I'm going to be left with is the shaded area that's still in there from the hexagon. All right, so let's do the area of the rectangle first. That's going to be really fast. Area of the rectangle is going to just be 18 times 22, which is going to be 396 units squared. All right, let's do the area of the hexagon now. Okay, well, we know that this would break up into 6 equilateral triangles. I can just draw one of them and then, multiply by 6, because I know that there will be 6. I'll just draw this one over here. I know that it's the regular hexagon, so if this side over here is 22, then all the sides are 22. And then when I go to split this in half, I know that this, when I split that for the height, that's going to be 11. This side would still be 22 because it's an equilateral triangle, but the height here is 11 root 3. All right, so I've got this. If I just am looking at this one triangle up here, I've got a base of 22. I've got a height of 11 root 3. So the area of that triangle would be 22 times 11 root 3 divided by 2. And when I do that, I'm going to get 121 root 3. So that's the area of one triangle. All right, so the area of the hexagon would be 6 of those, right? There'd be 6 equilateral triangles. So 121 root 3 times 6 would give me the area of the hexagon. 121 root 3 times 6 is 726 root 3. And that's also right, units squared. So my shaded now, going back to the shaded, I've got to take that hexagon, 726 root 3, and I'm going to subtract the rectangle, 396. Now you'll notice these are not like terms, right? The hexagon has a root 3 on it. The rectangle does not, so I'm not going to combine those. You could multiply 726 times root 3 in your calculator and get a decimal and then subtract 396 from that. But yeah, this is a lot of times when we get into high school math and beyond, we like to leave our answers in exact terms like this when we can. So 726 root 3 minus 396 units squared would be a great answer for that shaded region. All right, thanks for watching. Bye.